This video will talk about embedded electronic system in a very chop manner. Alright, chapter 1. Okay, so embedded electronic system is system that are not primary system in order to improve a certain system. What I mean, primary system of a washing machine, for example, is that you want to actually calculate the number of water level, because it's critical to ensure that the level of water level could better wash your clothes, right? However, in order to decide the water level, you need a certain sensor somewhere, and this sensor will pick up the weight of your clothes, the amount of clothes you put inside. So this sensor will send to a certain system and feedback that okay, maybe it's 5 kg, so therefore send a certain amount of water with a certain amount of water level. And therefore this sensing device that do this thing is an embedded system. Because it's embedded, it sort of improve your primary purpose. Your primary purpose is to get a water level, but in order to do that, you need something, and that something is considered embedded. Alright? Therefore, there are 5 approaches to choosing the correct embedded system. Alright? Approaches are simply all these approaches that I'll be discussing. Alright, so I'll discuss in a chop manner. Approach is to buy a simple IC. A IC board is something like a breadboard, for example, and then you put in whatever you want over here, you put in over whatever system you want over here, and this system will help you to calculate a certain stuff and feedback. Alright, so this is just a simple IC system, and then you connect everything. Alright, the second approach is to just buy a computer. A computer can compute anything at all. Alright, it can compute almost anything, but is it necessary? Because it's expensive. Alright, if it's talking about ATM machine, then it's using computer, because it's gonna have a hell lot of data, you're gonna download data and then dispense money and things like that. So therefore computer can be used for ATM. Alright, for simple system, simple IC will do. Alright, for approach 3 is application specific in IC, integrated circuits. Alright, then this IC is no ordinary breadboard or simple IC circuit. It's something that is really very complex, and therefore this is only specific, application specific IC. Okay, therefore it's special purposes that deals with large scale specific stuffs. Before I go to approach 4, I just want to go to approach 1, is that discrete components is like a timer or whatever little stuff. Alright, very simple stuff, and then you sum it up, or in other words, you add them all together into a breadboard or certain IC circuit, and then that's it. It's a simple circuit. So therefore it's a discrete components. For example is transistors, capacitor and things like that. Configurable hardware is the approach 4. Instead of transistor, capacitors and things like that, inside the breadboard you put a certain programmable device. So this device, when connected into a PC or whatever, you can program it. Alright, you can program what you're gonna do, and then you output to a certain stuff. So this is somewhat a configurable hardware, and therefore this piece of programmable hardware is something that you can program. Lastly is microcontrollers. It can perform very simple tasks. It's somewhat like a smart chip over here. If you're talking about microcontroller or microprocessor in this case, alright, microprocessor in the past is actually this one, this huge chunk over here. Alright, microcontroller is simply this one over here. Alright, for a microprocessor or microcontroller in this case, or other words microcontroller, alright, in this case, if you design things in terms of a small scale and run very fast, then you're gonna have a lot of heat, right? Because if you run very fast, you're gonna have a hell lot of heat, and if it's so small, then this piece of microcontroller will be very hot. If you have a larger surface area, when you run, at least the heat will be dissipated more easily, right? Something like that. This is somewhat of a setback for a microcontroller, and that's it. This is the first chapter. Goodbye.